Good afternoon. I'm Jnana Bharati on behalf of Machine Learning for Australia Community of Practice or ML4AU CoP. I welcome you all to this session today, and especially I thank you for taking the time on the eve of the long weekend. Today we have very interesting session from Associate Professor Quan Bai, followed by ML CoP meeting. But before I get into this, let me acknowledge the country. We acknowledge and celebrate the first Australians on whose traditional lands we meet, and we pay respects to their elders past, present, and emerging. So today, and again we get into the session, there is a very quick housekeeping. We welcome you all, and if it is okay with you, please sign up in the Google Sheet provided. There are a couple of questions that we request answers to regarding your interest in ML4AU and the future participation. And the data will only be used regards to ML CoP events. And also, if for those who do not attend today, there will be a survey that's forthcoming as well. So with that, it's a good time to segue into the talk today. Today's talk is by Associate Professor Quan Bai of University of Tasmania. And the topic is very interesting actually. It's AI facilitated isolations in human society. Quan is an associate professor at University of Tasmania. He has worked at Auckland University of Technology before. Quan graduated from Wollongong University in 2007 and 2002, and he also completed his bachelor's degree from Tianjin University, China. Quan works in a number of interesting areas, including artificial intelligence, software, programming, and so on, and particularly also agent-based modeling, and particularly multi-agent modeling. So with that, I will let Quan take over and continue this his talk. Thank you.
I'm currently associate professor at the UTAS and also leading AI research, active AI research group at the School of ICT. But before that, actually, as Ghana said, I graduated from Wollongong University, and then I worked as a postdoc in CSIRO for 2.5 years. Then I moved to New Zealand, to Auckland, actually worked there for 8 years. Then I moved back to Australia in 2019. My research has been mainly focused on machine learning, data mining, multi-agent system, and agent-based modeling. And recently, I also look at the AI applications in different areas, for example, fishery and health, because actually UTAS has very strong research groups in different areas, for example, forestry, agriculture, and marine science. So we actually have a lot of collaborations with other schools to develop some AI technologies in different application areas. All right, so let's come to my topic today. So my talk today will be about influence okay, and also the relationship between human influence among human and AI. So actually, I had some email conversation with Ghana before the presentation, and he mentioned, okay, so this group actually maybe I don't need to focus too much on technical side, but in general talk about the problem or the issues brought by machine learning AI model. So okay, I try to minimize the technical part of this talk, but anyway, I just want to explain the problems. Actually, some problems we have been investigating, and some problems actually we are all facing. So influence is everywhere. So, we are human in human society. We live in, among others, we live within influence. Okay, so in general, influence means something like the opinions, human opinions of behavior, which may be impacted by the surrounding neighbors or human neighbors. For example, it can be your friends, can be your colleagues, or can be your classmates, etc. I always want to give this simple example. Actually, this is a real example from myself. Actually, last Christmas, and my daughter suddenly asked me, okay, Dad, can I have a elf on the shelf as the Christmas gift? Okay, and I asked her why, and she said, okay, because several classmates of her brought this toy and this book to the school. Okay, actually, I never before he told me that actually I didn't know there's such a toy or such a book. Then I suddenly found, okay, before Christmas, this is a very popular book and popular toy in all supermarkets. In Coles, actually, you can easily find them. Actually, they easily sold out because it's very popular. So this is actually a very simple example of influence. Obviously, my daughter's opinion or her preference was greatly impacted by her classmates or her friends. Okay, and with the application, with the nowadays we all have a lot of internet applications, mobile applications, and then influence has been applied in different areas. For example, in marketing area, we have what we call word of mouth marketing, which means we try to use some viral marketing strategies to help the companies or help the shops to try to promote their product or their information, etc. Okay, you can also easily find actually social media has become very popular, and sometimes a lot of popular things and suddenly been circulated on viral, circulated on different social media platform very quickly. And meanwhile, you can see nowadays political campaigns are another big area. Actually, they use influence. You can see nowadays a lot of political candidates. They start to when they prepare for all the political campaign, they always try to find some what they call celebrities to help them to promote their ideas or promote their opinions, etc. Okay, and my group actually since 5 years before, actually we start to work on how to use some AI method to model and to analyze influence. Okay, we build some simulation environment and use some machine learning and agent-based modeling to analyze influence propagation process, and meanwhile to generate some influence propagation strategies for different purposes. Okay, again, today's talk is not a technical talk. So, however, you can see under influence propagation modeling, originally this is not a computer science research question. However, we also use a lot of AI method, actually investigate a lot of AI approach, which can help us to do influence propagation under different purposes. For example, the most classic problem will be influence magnification, which means let's assume you have a limited resources, okay, and then you want to recruit some people which can help you or your company to promote some information or product. Okay, then what is the optimal approach to do that? Okay, and this is actually the most popular problem in influence propagation modeling. And then based on that, we also propose some other method to do influence minimization, which means let's say you have some negative, if you have a company, you have some negative information, okay, circulated in the social media, which is about some product or something about the company, all right? then what is the best strategy for you to minimize the influence? Okay, and we also work on influence maintenance and also influence aware instrumentalization, which means, okay, if you take the influential degree of different users in a social network in consideration, then if you want to incentivize, provide some incentivization to the users towards certain purpose, then what is the best way? Okay, so yeah. But anyway, I'm not going to focus on this topic. However, if you are interested, you are more than welcome to have a look on some paper we published before. And actually, we have some detailed introduction about different AI and also agent-based method for these applications. All right. Today, my topic will be about isolation. Okay, the impact of AI to isolation. Nowadays, people, when we communicate, we know influence actually, traditionally influence means, the impact among human. All right, that's because traditionally actually human, we need to communicate directly, physically. Okay, but nowadays, our lifestyle has been changed. Okay, by those fancy ICT technologies. Okay, so I always like to use this picture. For example, if you have some dinner party together with your friends, okay, this is what happened before and this is what happened now. Okay, so which means everyone actually spend too much time on their mobile phones, on their computers, on their tablets, etc. All right. Then actually, as we start to think about the question, who are you actually communicating or interacting behind the screen? Who is that? Are you actually communicating with a real human, okay, or friends, or a fake friend, or fake human, or even some AI robots? Okay, of course, by using different applications, we believe we are interacting with different things. For example, if we simply want to watch some video clips and browse some news, okay, we believe we are consuming some information which actually were recommended by some AI algorithms, or with or without your awareness. Actually, there are some AI algorithms behind that. When we use some communication tools like WeChat, in China, WeChat is the most popular tool, or something like Facebook Messenger or WhatsApp or etc. Okay, if you communicate with others, okay, of course, this is a very important tool for you to communicate. But meanwhile, we also don't know. Sometimes, for example, there are always some news say, okay, someone fall in love with someone, and they always communicate by using WeChat or WhatsApp, and eventually they found actually the person he or she is communicating is actually not a real person. It's something like a bot, or maybe a man or woman pretending to be another man or woman, something like that. Okay, we hear a lot of news like this. The thing is, we are not very sure. We are living in a virtual world, okay? But what is behind the virtual world, we are not very sure. And another story actually I want to talk about is actually, again, this is a real story happened to me. During especially in the first 2 years of the pandemic. So because of the lockdown of the border, not only in Australia, but also originally I'm from China, okay? So actually since the pandemic, I haven't been back to China to visit my parents for more than 3 years. Okay, it's more than almost 4 years. Okay, so then you can see video calls. Okay, video calls become very important. So that's why I regularly still call my parents, and then and they also want to see their kids, etc. And one day, surprisingly, my mother told me, actually asked me a question. I said, why Australia always, something like show up as a news headlines. Australia always appear in news headlines, okay, in China. I think about like the thing she mentioned with me, and then start to think about like, okay, of course, Australia is a very important country in the world. However, compared with the giant countries like USA or Russia or China or even Japan, I don't think actually Australia should always occupy the news headlines. Okay, then I try to find out why. Then I have more conversation with my mother, and then she told me, actually, I said, okay, where you got this information? And she said, okay, she's using a popular app, okay, a popular news app on her mobile phone to read the news every day. Okay, so which means actually because it's very handy. This is very handy, and this is actually the name. This is in Chinese, but it means the if I translate in English, the name of the app means today's headline. Okay, this is not a popular app in other countries outside China. However, it actually under the same company with TikTok. TikTok is very popular. I believe you all know TikTok. Okay, this all under the parent company of these two apps is actually ByteDance. I think you all know ByteDance. Some of you probably know ByteDance, but most of you probably know what is TikTok. Actually, ByteDance has several apps, and TikTok is the most important one. And then this is a news app, which is very popular in China, and a lot of people mobile users in China, they use this app every day. Okay, the reason why my mother always see Australia-related news in news headline is because we are living in Australia. Her children and her grandchildren are living in Australia, so sometimes he pay more attention on news or information about Australia. Then the AI or recommendation algorithm behind the app start to learn this preference from her. Okay, so next time when she open the app, all right, the AI recommendation algorithm will start to feed, okay, or recommend more Australia-related news to her. For old people like my parents, okay, they believe, okay, the most important news is the news that recommended to them. So they believe this is news headline. Okay, simple. And then I start to think about, so which means for these kind of softwares, people are interacting with the AI algorithm. Meanwhile, people are also influenced by the AI algorithm. So which means nowadays, by using all these fancy ICT technologies, human can not only be influenced by other human can also be influenced by machine learning, AI, or any advanced software products. Okay. However, we all know that when we first have the internet, we believe, okay, internet actually open a new gate to all human, okay, because actually it's much easier to read or to watch, different type of information all around the world without any boundary. This is actually one big promise from the internet. Okay, we believe actually it will be much easier for human to gather information in different sources, okay, and then start to see opinions from different people. But actually, ideally, that means internet supposed to provide us a more open world, okay, rather than more isolated world. But is that the case? Actually, from this real story, I start to think about that, okay? And because we have done a lot of research on influence, then I think in this way, okay, how about we do some simple simulation? Because it's very hard to conduct some real world experiment. How about we do some simple simulation and try to analyze with or without the AI algorithms, okay, is people become more isolated or people become more open? All right, so then we start to work on this topic, and we actually, in particular, look at two types of isolations. And the first type is called filter bubble. Filter bubble actually means for any human user, if he or she start to live in a personal information universe, and this personal universe become very focused on very narrowed area of information, or narrow type of information or opinion, okay, and which means when the people start to consume more information, it won't help him to open the topic or open the opinion, more openly. Rather than that, he actually start to form a kind of information bubble surrounding him. This is called what? Filter bubble. And another type of isolation is called echo chamber. Okay, echo chamber actually means if you have a group of people, okay, they have some strong focus on one particular opinion or belief, okay, and then they even start to be very exclusive to other people who are holding different type of opinion or maybe some opposite opinion or information. Okay, for example, if I like basketball, and then if some, or maybe some, okay, maybe for example, if I'm a big fan of Sydney's one, and then suddenly some other some people start to say, okay, actually Jiran is also playing very well. My group of people start to exclude them from our communication rather than try to include them into communication. So this is actually a simple example of echo chamber. Okay, so we did some simulation, computer-based simulation, try to analyze with and without AI algorithm, what's the change, what's the difference between the formation of these isolations. Okay, so then what we did is we simulated some influence diffusion models. Okay, and we try to analyze the impact of AI-based recommendation algorithms in regarding to those two type of isolations. Okay, we also we create a simple model. This is our the framework of our model. You can see basically actually we consider two type of channels. One is the physical communication channel, which means human to human channel or link. All right. The other type of communication channel is actually generated from AI algorithms or AI platforms. For example, you can just consider that as your Facebook or some news recommendation ads, etc. Okay. And meanwhile, you can see we have two types of links among different human users. The first type of link is the actual link, which means you and your friends. The other link is actually is tabulated through the AI-based virtual link, what we call virtual links. Okay. We also use test two most popular recommendation algorithms, which is the user-based collaborative filtering, and the other one is content-based filtering. These two probably the two most fundamental, most popular recommendation algorithms. The first one is purely based on your surrounding neighbor's opinion, then try to recommend you some items. Okay, the first one is purely based on the information of the product you consume, then start to recommend you some similar information or opinion or products, etc. Okay, so in general, so this is the basic idea of these two recommendation algorithms, and we then try to simulate the influential probability. So which means different with the traditional influence modeling. Actually, we create a kind of physical influential probability. We also create the virtual influence probability. These two, the calculation methods are similar, but eventually we believe the overall influential probability actually is a combination of these two. Okay, it's a combination of these two. So actually compare with what we did before is actually we just consider two type of influential relationships in this simulation. Yeah, we then start to quantify, try to find a way to quantify the two type of isolations. So for the first type, we simply try to measure how unique information existing in the information universe of an individual user, which means if the user is under a very simple type of opinions or message, we believe it actually has higher filter bubble degree. Okay, our filter bubble effect is actually more serious for this particular user. And for echo chamber, then we simply measure the diversity of the message or opinion held by a group of people. Okay, suppose we have a group of users, and if they have a different type of message or opinion, then of course the echo chamber effect is less. However, if they only host a very small amount of opinion, that means they have a strong echo chamber. Okay, we have done this is just some math equation to quantify these two effects. And we conduct some simulation. We try different, topological, we try two different data sets. One with around 4,000 nodes, which is, and also almost 90,000 edge. The other one is a smaller network with only around 230 nodes and also around 2,500 links. Okay, and then we try to compare. In our comparison, what we did is, okay, we apply no recommendation algorithm to the network, to one of these two networks. Okay, then we measure the two isolation degrees, and then we also start to apply each of these two, recommendation, the content-based and also user-based collaborative, recommendation algorithm. Then measure it again. Then we start to do some comparison. And here is the result, and you can see the first two figures, okay, the first figure, okay, the figure A, okay, these two figure, actually indicating the comparison of filter bubble under without different recommendation algorithms. Okay, and the number here, okay, the y-axis actually indicating how diverse information the user holding. So which means the higher value it is, actually less filter bubble is formed. So you can see, compare the three algorithms, not three algorithms, two algorithms. Okay, the first, the yellow line means no recommendation algorithm applied. You can see without any algorithm, actually it got the least filter bubble effect. Okay, and then compare the two recommendation algorithm, you can see content-based filtering actually is got less filter bubble effect compared with the other one, which is user-based collaborative filtering. And then we also test the, by recommending different amount of message. For example, how many messages you want to recommend to the user. Okay, we try 20 different message, 40 different message, and 80 different message. And actually, you can see by using, this one is actually apply I think this one, I forgot which recommendation algorithm we use, but I think this one is use the user-based, content-based filtering. And you can see actually more information you recommend to the user, actually, bigger filter bubble effect will be generated. This is simply because the information actually recommend to the user are all based on the preference of the user, which means actually we start to select or filter non-relevant information based on users' preference to the user. Okay, that means it's a kind of reinforcement to the user's focus on one particular type of opinion. And on the other side, we also compare the echo chamber effect. And surprisingly, actually, for this one, you can see the lower value of the y means actually lower effect of echo chamber. But for this one, you can see actually surprisingly the two recommendation algorithms actually can reduce the echo chamber effect compared with no recommendation algorithm applied. The reason for that is because no matter which algorithm you use, you still try to create some virtual links between the user and more users, rather than ask them to communicate with the physical users with the physical link only. So the virtual link actually is tackling more broader range of network for each individual user. Okay. However, actually, if you look at the value, actually it won't change too much, because obviously, for example, without any recommendation, the number is around 0.91 or something, and the best case you can get is still around 0.84. So which means actually yes, it's slightly less, however, not very significant. Okay, and we actually report all these simulation results in a EJK paper this year. Actually, we submit a paper in a special track of EJK 2022. EJK is a top conference in AI, and the paper got accepted. Actually, my student just came back from Europe after they present this paper in the conference. All right, so this is pretty much what I want to introduce today. However, in general, what we found is, based on the simulation result, we believe AI algorithm, especially AI recommendation algorithm, can actually accelerate the filter bubble effect in human society, okay, which means actually generate more individual isolations in human society, okay? And on the other side, for echo chamber, actually AI recommendations algorithms can slightly, temper the effect, which means reduce the effect. So, but however, this is still based on our simulation work. Maybe in some special applications or in some special scenarios, maybe this is not the fact. However, based on our general simulation, we believe actually AI algorithm can reduce the effect of echo chamber slightly. Okay. However, it can greatly enhance the effect of filter bubble. Okay. So what's next? Some future work. So, and also some discussion point. Shall we start to think about, of course, for all recommendation, AI-based recommendation algorithms is purely based on usability. When we talk about usability, that means, okay, how to find out the preference of users, and then recommend those preference, some information or product related with preference to user. But on the other side, actually this will increase some isolation effect. Okay, then some discussion point can be, shall we actually really consider this negative effect when we design these algorithms? Okay, or in the other word, shall we actually develop some responsible AI algorithm in feeding or recommending information to human users? Because nowadays, human users, they are not only use these tools to communicate with other humans, they actually start to communicate with something like AI algorithms or even machine learning algorithms, or at least it's a kind of communication between machine and human. And the other question is, okay, if we want to do that, what is the best algorithm, or what type of algorithm we can design which can still make it usable, which means we do not want to recommend some irrelevant information or product to the users, meanwhile to make it a little bit responsible. Okay, I think this is something we can consider, and also we also have some other works keep working on this direction. Yeah, so this is what I want to talk about in today's presentation. Yep. Thank you very much. Any questions?
Thank you, Ron. It's actually a wonderful presentation, and most importantly, I love the way you set it up, because I mean, you had a real life observation, and then you formulated your hypothesis, and then you are testing it with agent-based modeling context.
Yep.
So that is exactly how a design of experiment, or how a simulation model should go from a real problem to actually test the hypothesis. So you have mentioned about this echo chamber versus what you call
filter bubble.
Filter bubble.
Yeah.
What is an echo chamber? Is it a real world simulation, or that is also a digital?
No, echo chamber actually originally the concept is not from computer science. It's actually from social science, I believe. Echo chamber means you have a group of people or community, all right? They hold a very strong belief on some opinion, all right? And they even start to be exclusive for any people who are holding different opinion or some opinion, some opposite opinion, especially opposite opinion.
Sure.
Yeah, and this is not a very healthy community. Okay, it's not a very healthy community because it's very easy for the community to go to very extreme direction.
Of course.
Yeah.
But the way you set it up, did you set it up digitally, or it's there is also a physical component? Because I see in one of your slides, slide 11, I think if I remember right, that you had sensors.
Sorry, sensors is just a term used here. Sensor, that means human users start to observe information.
Okay.
For example, so in this one, okay, so we didn't, the difference between this one and the simulation of a social network is, this one actually we start to introduce the AI recommendation platform, which means human, they besides their communication, direct communication with other human users, they also communicate with the AI algorithm, the AI platform. Okay, just like when you open any app, all right, Facebook, the Facebook will start to recommend you some information. Okay, so in this case, if you, for example, if I read a post by someone on Facebook, that means I start to establish a virtual link between me and the author of that post.
Sure. That's great. I have more questions, but let's open up to the audience. If anyone has questions, please do. This is such an interesting talk.
Hello, is it Dr. Bai?
Yes.
Yes, thanks very much. It's Terry here. Can you talk to us a little bit about the generalizability of your findings based on your sampling or the population group it is that you conducted this study on? Is it based solely on a select group from social media, or sort of active, sort of consensual participants, etc.?
Oh, sorry. This work is based on simulation. So we didn't recruit actual real users because of otherwise it's probably not easy to set up because of the ISIC and data privacy issues, etc. All right. However, we do have some other work which is related with some natural language processing project. Actually, use some real data from Twitter, because Twitter actually provides some open data which can be used for different type of research, including NLP or social network analysis, etc. But this particular work and because it's very hard to actually get set up the environment based on our requirement for in a real environment. So what we did is we used two topological data sets, which is these two data sets. Yeah, these two. One is the eco Facebook and the eco Twitter, and these two only provide the topological structure. Okay, and then we start to simulate. We just use agent-based technique to simulate humans' behavior of consuming information under different settings in this environment.
Thanks for that. Just to carry on a little bit, can you tell us a little bit about the limitations that you understand from this approach that you've taken?
Limitation, of course, this is still simulation-based work. All right, so which means one thing is I would say the simulation compared with real applications, the setup is still too simple. All right, so of course there's a lot of real world factors or parameters we didn't consider or we cannot consider. All right, and meanwhile is we only considered two simple or the two most basic recommendation algorithms, which is a content-based filtering and user-based collaborative filtering in this experiment. So we didn't consider too many recommendation AI algorithms into this simulation. Okay, and also the information here is also, you can see is a simulated information, which basically it's not the information, it's actually a simulation of the user's behavior rather than actual, consuming or reading or posting some information.
Okay, thanks very much for that, for your responses.
Well, this is a preliminary work, and we just started to conduct in this year. Actually, previously we have been focusing a lot on influence propagation modeling, but this project actually was started early this year. So we start to look at the impact of AI algorithms to human society. Is there some negative impact of AI algorithm in human society?
That's great. Any other questions? So while people think about the question, I do have another one. So in the face of information, when you present new information, how does the agent make decision? How is the utility function structured, or how is there anything special about it, or?
We have two, actually in this simulation, we have two types of agents. One is to simulating a user, or we call user agent. The user agent actually is selecting information based on, they have a predefined preference, and then they start to take the information based on the probability which is associated with the preference, and also the topic of the information. For example, if I'm interested in basketball, if there's a topic about basketball, then I have higher chance or higher probability to take that information. All right, but if my interest is basketball and if there's information about soccer, then I have lower chance. Doesn't mean zero, but however, I have a lower chance to take that information. The other, you can call it agent or you can call it some recommendation algorithm. This is a provide recommendation, which means, okay, based on these two different recommendation algorithms, all right, and then how to prepare the information you want to recommend to the user. But this one, the implementation will be based on the two recommendation algorithm. One is the content based, the other one is collaborative.
Sure, thank you. So there's a predefined affinity for the type of information, and then it consumes based on that.
That's
we
right.
do have one. Thank you. We do have one question from Mohammed.
Yeah, I have a question. Thank you so much, firstly, from Professor. But actually, I have some couple of questions. The first one is regarding to the experiments that you have shown, actually, the one slide that we are currently on the screen. And one of them is Ego Facebook dataset, actually. So what I assume is that when we talk about nodes or features, we actually talk about the profiles of users. And might be during these experiments, as you mentioned earlier, that due to privacy reasons, we might have done some kind of anonymization to remove the actual attributes of the user. So while removing the actual characteristics of the real user, how realistic these experimenters are in our real society? If we are anonymizing and if we are hiding the actual properties, how these experiments are like realistic in a
this is a good question. I can only say that the simulation experiment we conduct is a simplified and simulation based environment. And on the other side, it's very hard to conduct this type of experience in real network unless you really set up some some social network, some social media account, and then even form a small social media group to conduct this kind of information. But I agree with what you said. It's somehow very hard to compare whether this one, because it's a very generic, this is a very generic simulation, and this is a very simplified simulation. So it's very hard to say or comment whether this one can actually, what's the difference? How accurate this kind of simulation is. But this is actually also one limitation of this type of research. I agree with that.
No, I think that looks great. So following this question, actually, I also worked around, I actually also did research around context awareness. And one of the challenges that we faced is like modeling of static models and then dynamic models for these kind of situations. From what I can assume from these experiments, that currently these are static models. What if we are aiming to build a dynamic models to adapt daily emotions of the users?
You can create a dynamic model. Actually, some factors in the simulation model we use is also dynamic because we are talking about influence. Influence is a dynamic process. However, I think the key problem is how can you verify, even you set up a dynamic simulation or dynamic behavior, how can you verify or validate whether the dynamic behavior is actually humans' behavior or not? I think this is the key issue. You can, by using agent-based modeling, by using some AI techniques, we can always simulate some dynamic behaviors or dynamic systems. But actually, how to verify this kind of simulation result or behavior with real data is different. It's still hard. Especially, if we talk about human society or human social network, then you may get different result if you try it in two different group of people. I mean, real people. Same setting, you may totally get two different result. So we can only focus on a very generic level and then simulate some simple behavior or some common behaviors based on some defined behaviors, and then to see what's the result.
Yeah, that looks fantastic. So the last thing that I just want to just get an opinion from you is like, in terms of the role of AI actually. So how we can minimize the adverse impact of an undesirable influence using AI. How we can minimize this undesirable influence actually using AI.
So one thing is actually we start to look at this problem. Okay, the one thing is if we take this into consideration, then that means we probably, when we design the utility function for the AI algorithm, we not simply look at the preference of user, for example, but also these factors, for example. All right, so which means you look at the preference in your calculation of utility, you consider preference, but meanwhile about these negative effects, for example. All right, so basically you try to find the AI algorithm try to find a balancing point which consider both minimize or mitigating the isolation effect, meanwhile also consider the preference of user, which is related with the usability of the approach. This is my current thinking actually.
Okay, great. Thank you so much.
Thank you.
But of course, this is is still an open research question, I believe. So yeah, I think there can be much better ways to do that, or smarter ways to do that. We cannot consider the social well-being only, or good effect only. Then that means the recommendation algorithm won't be used by anyone because it has nothing to do with user preference. That means user won't use this app anymore. But meanwhile, if we only possibly learn users' preference, that means we may generate this kind of effect. I think this paper, the biggest contribution is actually try to simulate and prove AI can somehow generate more isolations in human society, rather than the initial promise of internet, which means okay, people will have a much broader range of information sources, and people will have a more open mind in the internet world, in the world of internet.
Absolutely. Absolutely.
Yeah. Thank you so much.
And, thank you, Mohammed, and thanks, Terry. Earlier, are there any other questions?
I have a question. Perhaps it could be evident from the statistics here. So you mentioned two algorithms which you used, the user-based collaborative recommendations, and the second one is the content-based.
Yeah.
So which one creates lesser impact of isolation, or like is there any better algorithm which does create less
Actually,
effect? Yeah.
Based on the simulation result for filter bubble, you can see the content-based filtering actually generate less filter bubble effect compared with the user-based collaborative filtering. Yeah. I think the reason is because user-based is purely to try to use people with similar preference, people's selection, people's choice, a similar preference, and recommend their new information to you. For example, if you like basketball, okay, I also like. Maybe we don't know each other very well. However, I watch a game that you never watch, and then the algorithm will recommend that game to you. However, that actually will make our mind more focused on basketball.
Yeah. That's a very, very interesting paper. I really liked it, and I can relate it to a couple of instances in my personal life as well.
Yes. Okay.
My kids watch, let's say, one of my little one. She started watching Peppa Pig, and YouTube is now filled up with full of Peppa Pig recommendations and nothing else.
Exactly. They are doing. On one hand, you can see these algorithms. They are doing a good job because they can learn humans' preference more accurately. Okay, but on the other side, you can see the negative impact from these smart or accurate recommendation algorithms.
How can anyone overcome these effects?
It's a very hard problem, hard question actually. It's $1 million question actually.
Yeah, and that's a tough one. Yes, I don't know if AI is doing a lot, definitely, but we should look at ways of overcoming this.
So That's great, Alim. Thank you. And are there any other questions?
I had a quick
Yes.
question.
Yes,
I was thinking about like the echo chamber versus the filter bubble, and the way that I guess I think of it is the echo chamber could be like I guess Reddit and the different groups on Reddit where people go and talk, and then the echo that'd be the echo chamber, and then the filter bubble could be Google. Google searches, where I know I've had discussions with people about like using R, the R programming language for machine learning. Like, oh yeah, nobody's using R, because like whenever you search for something on Google, it always shows you Python. And it's like, no, it's showing you Python because that's what you searched for in the past, and it's learned that. And if you did something else where it's more relevant to what they would be interested in, because it's they code in Python, they don't code in R, where it's the opposite. And for this, it's is there much of a push? Because I haven't heard much about Google wanting to stop that from happening, because it feels like that's what they want to do. Like that is their goal, is to give me what is most relevant to me at the exclusion of other things.
From my knowledge, actually, I understand the government, at least some government agencies, for example, CSRO, they start to work on what we call responsible AI, and which means by considering some problem, not only this issue, but of course some other issues generated by software product or AI product, and what is the role of the government, which can something like provide some guidance or some legal guide for these issues. And of course, it's still a little bit too early to say what may happen. However, I think the government start to look at these kind of issues. But eventually, what will happen? I don't know. As a researcher, I don't know. However, I strongly agree with you. The problem is even worse, because some software tools, different platforms may be under the same company and they share data. For example, if you search something on Google, then on YouTube, you may see some advertisement on YouTube. Okay, because actually Google and YouTube, they are under the same parent company. Okay, they are same corporate. So, and however, not many people understand that. People will believe, the information provided to them, especially people without too much knowledge in ICT. They be like my parents. Okay, they believe the information they received became important or popular, but actually they didn't know this is because some algorithm behind those different platforms actually learned their preference and then prepared some information and feed some prepared information to them.
Yeah, that was, I guess, it's kind of a question and also kind of observation of, we can do these things as researchers and play and go like, yes, this is damaging to society, or this is doing this. The echo chamber is a harder thing, because that's just humans do that themselves, and they form in groups of like-minded people, and then that just happens. But then the filter bubble part is more, that's a different thing. That is AI, or that's whatever doing those things. But to get the people that are doing it, like YouTube and Google and all the other things that are doing the recommender type things, for them to stop doing that, whenever that's been the way they've built their company up to do things, that's the harder, I guess that's the harder part. We can say, yes, it's bad and you're doing this like that, but it makes us more money, so we should keep doing it. And the
efficiency and effectiveness are often a trade-off. Doing the right thing and doing it the way that makes more efficient. Yes.
Well, actually, similar thing happened in other industries as well. For example, if I have in Tasmania, for example, if I have a salmon farm, all right, actually, if you only look at the profit, actually, the salmon company, they shouldn't, or they doesn't want to consider the impact of the environment, the pollution or whatever the environment they generated from a salmon farm. Okay. However, to get the social license, they do have to consider that. That's why they need to take some actions. They need to spend some money to protect the environment or to remove the carbon footprint or whatever. This is actually similar. Actually, when of course, if you want to make your software more or algorithm more popular or more adopted by more people or earn more money, the only goal is to make it useful, more accurate. But if we can also define some social license for the software industry or for the AI industry, it seems like something then, so that's why I say the government, should be something need to be considered by the government rather than, it's hard for the industry to really start to generate some solution without the influence from the government or requirement.
There is a need for regulatory
Exactly.
intervention. Yes.
Yeah, exactly.
Thank you. And if you don't have any other questions, anyone? This can go on. This is such an interesting topic, actually. And, go on.
And again, it's my great honor to be invited to this series. And if you are interested in this topic or want to have some other discussion, feel free to contact me, and I'll be more than happy to answer questions. This is my email address, and yeah.
If not anyone else, you would certainly be hearing from me.